We're working in section 1.8. We're solving equations and inequalities with absolute value. In the previous video, we learned 4 rules that we can use to solve different equations and inequalities with absolute value. And we had a few examples to try to help us understand why the rules are what they are. Now in this video, I'd like to work a few more examples, and the focus will be on applying the rules. So let's look at number 1. We have the absolute value of 2x plus 1 is less than 7. And so the first thing you want to do is recognize the absolute value there, and then you want to think about which of the 4 rules would apply. And so I bet you see that rule number 3 is the one. It has rule number 3 has a variable expression inside absolute value on the left side, and it has a constant over on the right, and furthermore that constant is positive. And so if we can just apply rule number 3, then we should be in good shape. In each of these problems, ultimately what we're going to do is we're going to drop off the absolute value, but there's always a consequence for doing that. And so, and I guess that's the tricky part, is to keep track of what the consequence is, and then maybe even harder to understand why we're doing what we do. So again, I went through the why in the last video, and now in this video I really just want to apply the rules. Okay, so number 1, we can drop off the absolute value, and we just have 2x plus 1 is less than 7, but there's a consequence. So look over here at rule number 3, and you see that when we drop off the absolute value, we actually wind up with a 3-part inequality. So I've already written out the second part of that inequality, but I need to come at the beginning, and I need to put negative and then the value of a, and then a less than symbol. So negative 7 is less than. Negative 7 is less than 2x plus 1, which is less than 7. And so now I have a 3-part inequality. We learned how to solve those in the previous section. We just want to subtract 1 on all 3 sides. And then we want to divide by 2. And we have our answer. We can write the answer as a 3-part inequality, and we can also write it in interval notation. Remember, the 3-part inequality says that the variable here in the middle, x, is between negative 4 and 3. So x is between negative 4 and 3. So we can put that in parentheses with a comma and a box around it to show that'll be our final answer. Okay, let's go on to the next example. This time we have the absolute value of 2x plus 1 is greater than 7. We compare that with rule number 4, where you have the absolute value of the variable on the left, and you have a greater than and then a constant on the right. And so that looks like the rule. Of course, the part that's intuitive is to just drop the absolute value away and just have 2x plus 1 is greater than 7. And that's correct, but that's only half of the story. There's a whole other possibility, and that's written here in the first part of this rule. It says that what's inside the absolute value can be less than negative a. So inside the absolute value is 2x plus 1 is less than negative 7. So we have these 2 inequalities to solve, and so we can go ahead and solve each individually. We'll have 2x is less than, let's see, subtract 1 to get negative 8, and divide by 2 to get negative 4. And then over on the other side, 2x is greater than 6, x is greater than 3. And we can put a box around that. And then we can also write that in interval notation. These are called disjoint intervals. They don't overlap. The numbers less than negative 4 begin with negative infinity and go up to negative 4. And then there's a union, and then the numbers greater than 3 would be from 3 to infinity. And so there's our answer in interval notation. Okay, let's see a couple more examples. Here is example 3. Notice this time we have absolute value on both sides. That looks like the second rule. Remember that second rule was just a little bit different from the others in that a on the right doesn't have to be a constant. It can have the variable. That can be an expression that includes the variable as well. And so the value of a doesn't have to be positive either. And so and the reason for that is because there's absolute value around that a. Okay, so what it says is what the rule says is that we can just drop off the absolute value on both sides. That's what this first equation is. And in the second equation, we have the absolute value dropped off, and we just insert a negative in front of the right-hand side. So let's see if we can do that. So the first equation is exactly the same as what we were given, except the absolute value is gone. And in the second equation, we'll just put a negative in front of the right-hand side. And then we can solve these two equations. These are linear equations that we learned at the beginning of the chapter. So we can subtract x from both sides and get 3x. We can add 3 to both sides and get 9. And then when we divide by 3 on both sides, we get x equals 3 for our first solution. In the next problem, we can go ahead and distribute the minus sign first. And then when we add x to both sides, we get 5x. When we add 3 to both sides, we get a negative 3. And then when we divide both sides by 5, we get our other answer is negative 3/5. So answer looks good. It's boxed up. We could also write that answer not in interval notation. That's not an interval. That's just two values. We can put it in set notation with the braces. We can write 3 and negative 3/5. And notice in set notation, you don't even have to write the numbers from least to greatest. In interval notation, we always write the smaller number first and then the larger number afterward. Okay, let's do one more here. So for this last example in this video, I have the absolute value of 8 minus 3x, and then a minus 3 is equal to negative 2. And so when you look at this, you should say two things. You should say it looks similar to rule number 1 because you have absolute value and you also have an equal sign. But you would also say it looks different from that first rule because the rule shows that the absolute value is alone on one side of the equal sign. And so, and in fact, that's true for all four rules, right? The absolute value of x is alone on the left side. So if your absolute value in this problem is not alone on one side, then that's what we need to take care of first. We need to isolate the absolute value first and then apply the rule. That's a really important idea. Let me say it again. We need to isolate the absolute value first and then apply the rule. Okay, so let's go ahead and add 3 to both sides. And we'll have the absolute value of 8 minus 3x is equal to 1. Notice now absolute value is alone on the left. There's an equal sign in the middle, and the right-hand side is a constant that's positive. So those are all the criteria for rule number 1. We can go ahead and drop off the absolute value and make 2 equations. In the first equation, all we do is just drop the absolute value. And in the second equation, we drop the absolute value and we put a negative in front of the constant on the right-hand side. Okay, so we can solve these 2 equations. So we'll subtract 8 on both sides. And we'll divide by -3. And x is equal to 7/3. And then we'll do something similar. -3x is equal to -9. X is equal to 3. We can write our answer in set notation. And we're all done.